Hello and welcome to this hands-on video. I am Toren and I'm software developer at dSPACE, and I'm going to show you the new battery data exchange protocol, which is implemented to ensure safety for EV charging. The main objective of the battery data exchange protocol is to ensure a real-time communication between the vehicle and the charging station, where critical battery parameters are transmitted in a regular basis. And the main motivation behind this is to enhance the safety, for example to prevent fire hazards. The background is that the state-of-the-art charging protocols like the ISO 15118-2 are mainly focused on standardization of the charging sessions and to make them more convenient for the customers, but they lack of detailed battery health monitoring. The protocol is mainly driven by the Korean regulatory authority, but there also exist more related specifications, for example the ISO 15118-12, which is still under development and also defines a protocol to exchange information between the EVCC and the SECC. To the implementation of the protocol, a so-called value added service is used, a VAS, and this runs alongside the main charging protocol, the ISO 15118-2. And this is done to enhance the safety without interfering the charging process itself. And it defines the transmission of relevant battery data, for example the state of charge, the cell voltage and current of every cell in the battery, the overall temperature of the battery, state of health, and even more relevant data. On this slide you see the base flow of the ISO 15118-2. At first we start by establishing the data link via powerline communication, and right after that a TCP server is started. And after that the V2G communication, so the real charging communication, is started. Of course at the beginning there's a session setup. And right after that there's the service discovery, where the charging point announces everything that it offers to the electric vehicle. So of course the how to charge on AC, on DC, or one phase, three phase. It offers maybe different payment options, and also the charging station can offer an optional list of additional services, so these VASs. And after that, maybe the electric vehicle only wants to charge, then we go directly into the ISO 15118-2 charging communication. But in this case we also want to start the battery data exchange, and therefore the electric vehicle needs more parameters about the service. So the charging station will send a service detail message where all parameters are given to the electric vehicles, so the vehicle is able to send the new battery data exchange messages to the charging station. And in the end, when the main charging session is stopped, also the battery data exchange protocol stops. Here we can take a look in more detail into the messages. So on the left side, the service discovery. We see here the service list. The name of this new battery data exchange protocol is the battery data VAS Korea. The ID is 61000, and there are even some more parameters here. Then in the service details we see, for example, the IP address of the charging station and the port where the electric vehicle will connect to, also the interval which defines how often such battery data is sent. And on the right side we see one single packet of the battery data exchange protocol. And it just contains all the relevant battery data, as you can see here. And now I'm going to show you a demonstration on how to validate and test the battery data exchange protocol. This is our test setup here. We see on the left side the smart charging solution by dSPACE, which simulates a charging station and can be used to validate and test electric vehicle charging controllers or even electric vehicles in a hill environment. And here on the right side we see our Bobby car, which is a simulated electric vehicle which implements the battery data exchange protocol. And yeah, we will then see how the packets are sent by the electric vehicle. Okay, now we take a look into ControlDesk, where we have plenty options to simulate the charging station and to vary parameters to manipulate the communication. The most interesting part is here below for us, the value-added service, and especially the battery data courier. We can here enable the VAS announcement in the service discovery response, as we have already seen in the presentation. Here we can enable the TCP server on the port 61000, which will only accept all the packets. And here at the bottom we see a counter for all the received battery data messages. So yeah, that's everything we need to do to enable the feature. Then we just have to plug in the EV on the charging station side. First we will start the Bobby car, so it is ready to charge. Let's take some seconds. And now I just plug in the cable, and then, yeah, as we have seen in the presentation, at first the data link is established, the power line communication, then the TCP server is connected, and after that the whole charging process starts together with the battery data exchange protocol in parallel. This takes a while, but now it has already started, so we can go back to ControlDesk and see what's happening in here. Okay, yeah, as we can see here, we already are in the charge loop. The charging status messages are sent and received. And when we go down here to the battery data courier, we see that also the counter for the received battery data messages is increased every 3 seconds. So now let's take a closer look into the communication itself. So there are 2 options, because the communication is based on Ethernet, so we can we somehow need to have a connection to the Ethernet interface. In our test setup here, our solution offers a mirror port where we can just plug in our PC and capture all the traffic. In a real environment, we would need a cramp. It's a so-called CCS sniffer, which we can put around the charging cable, and then we can plug in the PC on this sniffer. Okay, so now I have connected our solution, so the mirror port of the DS5366 to my PC, and we will go into Wireshark and take a look at the messages. Okay, so I now can connect here to my Ethernet adapter, and we already see here very much messages. Not only the message we want to see, there are also some control messages and acknowledgements, etc. So I press here our small filter button, and now we can only see the relevant data. We see here request responses from the EV or EVSE. I will now stop the capturing here, so it's better to see. We can take a look into the messages here. These are the charging messages from ISO 118-2. As we can see, there is not so much information in these messages. Maybe here some max current and some status data. And here we have the new packets, the battery data packets, and we already can see here in the overview how all the data that is inside these packages. So when we look into detail here, we see the all the data of the battery. And also here are some diagnostic messages. So the decoding was successful. It matches one specific case, which is given in the specification of the battery data exchange protocol. And yeah, this is how it looks here. But now, since we have started capturing while the charging progress is already running, we don't have the session start. So I will now open an example trace. Here we can see the full charging session from the beginning. It starts here with a session setup, and here the service discovery I've mentioned before. And we can take a look into the message. We see here it offers the battery data VAS Courier service. And then in the next message from the electric vehicle, we want to get the details from 61000. And in the response, yeah, we see all the parameters here. So the IP address and the port itself. And right after that, the battery data starts transmitting, and as we can see, every 3 seconds a battery data packet is sent. Now here, for example, is the state of charge in this packet. We see here it starts at 50%, and yeah, it goes on. And here at a specific point in time, we have a state of charge from above 100%. And here we can already see here this is colored red, so there's a warning. When we click on here, we can see the state of charge, a diagnostic message, the value is out of range. So the plugin here is already validating the battery data. So the Ethernet packets here are encoded as, for example, XC in the normal charging communication, and also this battery data here itself is encoded as is given by the new specification. And Wireshark is not able to decode everything out of the box. Therefore, dSPACE offers this Wireshark plugin we can see here. It is free and open source. You can find it on GitHub or even on the dSPACE website. Just download it, install it, and you can decode the full charging session as we see here. Now I have shown you how you can validate and test the new battery data exchange protocol using dSPACE products. Feel free to contact us. Thank you for listening.
dSPACE, your partner in simulation and validation.